I want to know what range of values, what could X be, and I would still be able to make a triangle. Let's review that really quick. Kind of get that out of the way. Then I'll go into all of it. So this is on your quiz on Friday. I think this is pretty easy. So I don't know if it'll be its own separate grade. Maybe I'll give you a couple different problems on it. I mean, really, there's no way to give you two different types of problems. There's only one thing to really do, and it's that right there. So I don't know if I can really make it two grade or a separate grade. Regardless, it should be an easy question. Everybody should get right. There's a simple process you follow for it. So if I say, what range of values could X be that would allow me to make a triangle? Remember, there's a rule that you have to have in order to be able to make a triangle with three sides. Oh, shoot, we gotta go backwards. All right, so first of all, what is the rule for triangles? It's the same rule as if I give you the three sides. Like I don't give you a variable, I give you the three sides. It's the same rule. It's just in this case, one of the sides is a variable and we have to solve for it. So what is the rule? Tell it.
Two smaller sides has to be greater than.
So, yeah, I'm going to do it one particular way. There are multiple ways to do it. The main piece is that you write the answer correctly. I'm hoping everybody can come up with the answer. So we take one of the short sides, call it short side 1. We add it to the other shortest side. Short side 2. So together, that's the two shortest sides. And then that has to be greater than the longest side. Now, when you have all three sides and numbers for them, it's pretty easy. Just add the two lowest numbers together. If, though, we don't know anything about one of the sides, so it's a variable, completely unknown, you have to consider two scenarios. We don't know anything about it. So what are the two scenarios? I'm going to go with how. What two things we have to consider when we do this? For this problem. Like, what do we have to consider? I don't know anything about X. I want to know if I can form a triangle. Not for X doesn't have to be more than 14, but before we get into the math, what do we have to consider? It's a little bit hard to understand what I'm saying. Well, it's not, so we're not solving for X yet. Slow down. What do we have to consider? Like, what's the trick? The tricky part of it. Got it. Or it might be what? Yeah, we don't know what X is at all. Maybe it's one of these sides. Like maybe it's one of the two short sides. But maybe it's the longest side. Like I don't know anything about it, so I can't just pick one thing and just solve one way. I've got to consider that it could be on either side of that inequality. So I have to solve twice and get two different values, and X has to be between those two. So maybe X, different color, maybe X is one of the short sides. If X is one of the short sides for this problem, what's the other short side? Yeah, 3's got to be short, right? 14 can't be here because 3 wouldn't be the longest side. So that's greater than 14. Now you just solve. So to solve for X, we subtract 3, and we get X has to be greater than. There we go. X has to be greater than 11. But again, that's not the only possible value, or not, I shouldn't say possible. That's not the only requirement. Because the other requirement is, well, if I just pick a number greater than 11, I might mess up and I might pick 100. Well, 100 is not going to work because then these two are the shorter sides and they're not going to be able to make a triangle if X is 100. So there's like a maximum value X can also be, because X could be the longest side. So if X isn't one of the short sides and it's one of the long sides, then the inequality would look like this. X would be over here. And what would my two short sides be then? It'd be the only other two sides, right? So it'd be 3 plus 14. That's pretty simple. We're just adding them together. And the way we read that is X has to be less than 14. You always read an inequality from where the variable is. So we said the final answer, the way we would write the final answer, X had to be greater than the difference of those two. So we just subtracted for the lowest number. For the high number, we just add this. That was the shortcut. So subtract them for the low number, add them for the high number, and then X is in between. And cannot be equal to. Do not put an equal to symbol underneath it. Because if it's equal to, it would be a line that just falls flat on top of another line. Wouldn't make a triangle. All right, so that's the review of that. Again, that should be an easy question. I wish I could break that out. Normally I do the quiz where all the triangle stuff is together, but just because that takes a little bit longer than the other stuff, I didn't want to try to cram it in last week since that was this quarter grade and we didn't have a lot of time for retakes on it. All right, so now back to the circumcenter. Any questions on that? And there were problems assigned. I'll just repeat it in case people weren't here. Well, it's up here. So the problems for that were page 385, 9 through 12. And then actually the IXL, I'm starting to write IXLs up here. The IXL is still BW7, which was the same one as down here. You might have noticed that IXL had some of these kind of problems, even though we hadn't covered it. So now on to, again, what is definitely the most complex that you'll have on Thursday. And we'll still be doing this Thursday, so we'll work more on it Thursday. We'll get through everything today, and then we'll review and practice more on Thursday again. What is the circumcenter? It's kind of a tough one to remember. Well, how is it formed? It's formed with one of the things we did before, midpoint. Has to do with midpoint, but again, how? Because there's another one that had to do with midpoint. Two of them have to do with midpoint. Vertex. Not from a vertex. It's not the one that's from a vertex. So it's midpoint, but not the one from vertex. There's a name of the thing. Yes, we use perpendicular bisectors. So we do use the midpoint because that's the bisector part, but we do not. Yeah. So this is all of them together. So we'll actually. Haven't gone over all of that. Let's back up and review the review. So it's formed with perpendicular bisectors. So we go from every midpoint. So we find the midpoint of a side and we draw a line straight through it at a 90-degree angle. So that's how this one is formed. So again, hope you're taking notes, or if you plan on using your book notes, make sure you're adding some stuff in because the book wording isn't always as simple. You take every midpoint. So again, circumcenter, midpoint is involved because we're basically using perpendicular bisectors, which uses the midpoint. The midpoint's associated with that. These are medians that we're drawing in because we're drawing in perpendicular bisectors. So oh wait, that's not right. Yeah, that's right. So remember, what other thing used midpoints so that we did? Another one that used midpoints. Why it gets tricky, like it's just a lot of stuff you're gonna have to keep straight. Recall some studying. There were two that used midpoints. One, you draw through the midpoint at a 90-degree angle. That's this one. One, you draw from the midpoint to something else. Actually said it a second time. Not an angle bisector, because an angle bisector doesn't have to go to a midpoint. So it's a lot to keep straight. So we are gonna, but what is that thing called? Actually, I'm sorry, I got that wrong. That is, we don't use medians in that. That's the other thing. That's what we use, medians. That's the one. A median goes from an angle to a midpoint. So if you had median on this one, we're racing. This one's perpendicular bisectors. So median, which I do want to still talk about median, but median, I don't have it on the screen. Here, I'm going to zoom out and just show you. So if we had the same exact triangle, there we go. Same exact triangle. Oh, now it's not going to let me. Try that again. Why is it doing that? I don't even have it on the. Let's try that again. There we go. Oh, no, don't want that. Triangle. There we go. Goodness. So if I have that same exact triangle, I could draw in median. So again, a median is from a vertex to a midpoint. And that formed the centroid. So the medians or midpoints would be probably somewhere there. And where was it? Hard to actually pick it because visually it doesn't look right to me sometimes. The bottom one does. So if I drew in actual lines, so if I went from angles through midpoints, kind of somehow got off the line, it's fine. Write that one down. So if I draw from angles to midpoints, that's medians. And that was the centroid. So these, I can see these two being, I mean, actually, even this I could see, because sometimes it looks like when you draw an angle bisectors, sometimes that looks like it's going through midpoints. So all three of those are going to be the ones that are tough. The altitude is pretty easy because you're going to draw lines that are at 90-degree angle. I mean, even that one, I guess, can get a little tricky. Is but the altitude doesn't have any math associated with it, so you don't have to worry as much about that. These all have math associated with them, like even beyond what we learned yesterday and last week. So in the ones that involve midpoints, so again, this is medians, which is also midpoints. The difference is it's not drawn at 90-degree angles, it's drawn from a vertex to a midpoint. So these are all really similar, and you're just going to have to do some studying. And then the main thing when we have the one through the midpoints, we need to remember, well, if it's through midpoints, we have a bunch of congruent segments. So this one's the same way. It's through midpoints, then we have congruent segments. Midpoint would be these little red dots. Actually, I can zoom in now. So these little red dots are the midpoints. These are not midpoints. Again, if it's an angle bisector, that does not mean you're going through the midpoint. So you may want to write that down. It doesn't mean midpoints here. I mean, it could happen to go through one like in an equilateral triangle or isosceles. It will go through a midpoint in those, but not guarantee. Like the other ones are drawn using it. This one's not drawn using it. It just might happen to go. Not midpoints if it's angle bisectors and incener. The key here is that we have angles that are the same length. All right. So that stuff you're gonna have to just memorize. Like there's no other way around. Gotta memorize those definitions because what I told you is I'm gonna tell you in a problem, I'm gonna say in the picture below, you see the incener or the circumcenter or the centroid or whatever. And that's gonna tell you what math to do because there's different math associated with each of these. Not just the midpoint math, not just the fact that you could set those equal or you could split the side in half. There's more that we're gonna learn today. And if you don't know the definitions, you have no chance of doing the math. Which means this could be a really low grade. You gotta remember or spend some time memorizing some of that. All right, so with that in mind, look at 347, I believe. Might be on 346 though. And again, the math itself won't be that difficult if you can just remember which one goes with which. All right. So here's the concept, I guess, and this is where some of the math will come in. Let's zoom in on just the way. So just circumcenter. I'm sorry, no. Yeah, just circumcenter. So here's the next piece. Again, once you've learned how each of them is made, and you've got it memorized, okay, if I know it's a circumcenter, that means I have midpoints. You need to know the name of that. So that thing is the circumcenter drawn by perpendicular bisectors. So if we have perpendicular bisectors and we have the circumcenter, that point of concurrency, we said when lines come together, it's a point of concurrency. It is the same distance from every vertex. So again, little tricky to tell. Oh, how can I? Oh, I think I can measure. Let's try this. Measurement tool, ruler. So again, I drew it in by hand, so it may not be absolutely perfect, but the circumcenter. So when we draw in perpendicular bisectors, all of these are right angles. Right angles to the best of my ability. So if I take that ruler, gotta be a way to turn it. I would think. Not. Oh.
Here's the circle right there.
Yeah, is that turn it though? Normally that just makes it bigger and smaller. Huh. Oh, there we go. So if I turn it, trying to get it about parallel to that line. So here, that's relatively, oh shoot, but I got to turn it to match the vertex. Not super easy. There's got to be a better way to do this. All right, so I had it right where I wanted it. Okay, there we go. All right, so that is about what? That's close enough. So from about, actually, it's pretty much dead on 0 to 6, right? So again, drawn by hand, so it won't be perfect. But all of those other distances, I do this the easiest way. Now that should be about 0 to 6. Oh yeah, that one's pretty much dead on 0 to 6, right? This one is gonna almost go off the screen. But again, 0 to 6, you can't see 6 is right there, right on the vertex. So the distance from, so again, here's your note, and it's in your book, but this is what you need to remember. If I give you a problem, and if I say in the picture below, you have a circumcenter. You need to know two things. Every side is split in half, so we're using midpoints. I mean, really three things. There are 90-degree angles at all of those intersections. So that's two things. And then the last thing is the distance to every vertex from that circumcenter, which could be inside the triangle. Like I think if you look in your book, yeah, if you look in your book, the circumcenter of both of those triangles on 347 is inside the triangle. So it can be outside, it can be inside, but the distance will always be the same. So if I had some lines drawn into each vertex, just like they do on 347, you see they're drawing in lines to the vertex. All of those lines are the same length. Let me just show you one thing real quick from the book, and then we'll move to the next piece. So here's the highest level of difficulty on this. Next. If I give you an image like that, I could say something to the effect of, I'd tell you that's a circumcenter. I'd say that. There we go. I'd say that point is the circumcenter of the triangle. And then I would say, and that's all I'd give you. And I would say solve for DE. That's the highest level of difficulty. How in the world would you do that? I'm giving you practical 0. Except all the thing I've told you is it's a circumcenter, and I give you two numbers. One of them is not even near D. Anybody have any clue? I'd be impressed.
Can you repeat that?
So again, I've given you, what does the 13 mean? 4.
Sorry.
Which one? Give me use the letters. So BD, so again, do what you know. Here's your process. Right, BD equals 13. Start working through it. Don't freak out. Don't be like, I have no clue. Do what you know. All right, well, I know that. I know what else.
DC.
So that's a big piece of it right there. So again, because it's the circumcenter, so there's got to be a way to solve it. So at some point, you may just have to say, well, the only way I could really solve this is if I knew this piece. Is there a way I can figure out this piece from other stuff? Somehow we got to, if we're solving for this, somehow we probably got to know something else down here. Well, the circumcenter, maybe that'll help you remember. Oh yeah, I think maybe that's the one that it's the same distance to every vertex, because I know this distance to this vertex. So maybe this is just the same thing.
Same for AD, that would be good.
So that would be 13 as well. So again, just figure or fill in what you know. And again, you're going to have to memorize definitions and know some of this, but you do that. EC is equal to FB. How would you make that distinct? How would you say that? I just said that would be in the picture. Well, you're talking about this 13, right? Yeah. Yeah, they'd have to give you some number. Yeah, absolutely. So let's back up and go with what's the definition of circumcenter? How do we make it? So say it again.
Or bisectors.
So bisectors. So what could we also write in then? We know we're bisecting every side. So we'll come back to that. But if that's not the bisector, that's the perpendicular part. If we bisected every side, don't we know a part of one of the sides? Say it again. If we know this is 10, right? If we know we bisected, then that's 10. I don't know how you're getting BF though yet. There's a way to get it, but we don't know anything about congruent triangles, right? We don't know any angles. There's nothing telling us any angles are congruent. There is. We're going to get to some of that, but I don't think we can say those are congruent. There are some congruent triangles, but can't say that one. There's another piece though that so now let's talk about the other piece that I'll say. So how are these created? Like they're created with a perpendicular, right? So what do we have? We have 90-degree angles, right? So I know I drew in those, or I know I created it doing that. Now, what did I tell you should jump into your head anytime you have a right triangle? Well, that's just the definition of right angle. Like there's a concept, a theorem. As soon as you see right triangle, I told you a squared plus b squared equals c squared. If you need to solve for the length of the side of a right triangle, and you know 2 of the 3 sides, a squared plus b squared. So that's how you solve. So again, just filling it out one piece at a time, though, shows me you get some concepts. Then if you can make that final connection of, oh, that's right, for right triangles, the sides follow that whole a squared, b squared, c squared thing. And if I know 2 of the 3, then I can solve. Doesn't matter which one you make, a or b. Oh, not plus. So that would be your equation. You would get the square root of 69, which we don't have a nice round, 8 point something. So again, just by filling in pieces, though, you're showing me you get the concept of the circumcenter. By showing me you understand these are right angles. By showing me this would be the big one, like you get a lot of points for this. Showing me you know all 3 of those are 13, because that's the main definition of a circumcenter is that it's the same distance from all the vertices. Showing me you know this was split in half. Again, those are all concepts. Even if you don't get to ever doing the math on it, like you're like, I have no idea how to solve for that, but I know all these things are true. You're showing me concepts. Concepts are what get you the most points or lose the most points. The math part, like actually solving out, gets you to A's and B's. You could just fill in the whole triangle, I'm sorry, the whole figure with all the like concept stuff, and still probably get a C if you did well on all the other questions. Similar on all the questions. So again, make sure you understand the concept, which is going to mean a lot of memorization. But memorization isn't difficult, it just takes some time. All right, any questions on that? That's a pretty good example of what I could do on a problem. Really good. What's that? Oh, it's a square root of 69, so 8 point, what would that be, like 8.4, 8.3? I didn't actually do it. Who has got calculator? Do the square root of 69 real quick, and I'll write it in. 8.3. Oh, actually, it's ED. So that would have been the answer. And again, that makes sense. If I got 10 and 13, looking at the figure, even if it's not perfectly to scale, it's probably pretty close to scale. So that would need to be shorter than 10. So 8.3 makes decent sense. All right, so that's pretty much everything. I mean, the main concept on that, from the circumcenter, the distance to every vertex is the same. That's the main additional concept for that one today. Any, I realize that. So I saw this. So this is 100, right? So this is 169. So I would get 100, 169. I would subtract 100. from the 169, right? 13 squared. You understand I'm getting 169 by just saying 13 times 13. It's not if I scroll, yeah, that stuff's not gonna move, it's just gonna stay there. Oh, we're having more room. Here, I'll come over here. So if I subtract that, I get a squared equals 69. Well, the way I saw, and clearly that can't be 69, that makes no sense. So whenever you're using the distance formula or square, anytime you have squares, probably gonna have to do a square root at the end. So the A, which is the length of that side, is the square root of 69. We just solved for A. And this equation comes from the fact that it's a right triangle. Like every right triangle, that's the relationship that the sides have to each other. All right, so why don't you try the check? Again, you don't know how to get to the final answer immediately. Put in what you know. Fill in the pieces that you know, based on the fact that you know that's a circumcenter. And the more pieces you fill in, the more the light bulb might kind of go on. You might be able to figure it out. It's 12. I'm gonna write that since I haven't changed the date. Hopefully this shows up. Can you guys see that? Attendance already. So, cool. Plenty of room to work on that. JV soccer game tonight. No, they canceled it. No, not tonight. What? I feel like you did that. No, I asked one of the JV girls. She told me it was tonight. Were you there last night? No. I know they announced that, but she told me it was actually tonight. You know, Anlika that plays. I have to look it up now. Yeah, because she was in my class and they said, "Oh, you got so there's also a soccer game tonight." And she goes, "No, it's tomorrow." Oh. I'll find out. They talk about varsity. No, actually, I know. Oh no, not varsity. Yeah, no, JV, yeah. Because I was gonna say I was up here last night. The soccer field, the lights weren't on. Yes, they did have an away game. The varsity, that's not yeah. Yeah, because there's only one coach, so they can't really have games on like varsity and JV, an away game and a home game. I don't know if they've ever done that. It's always, I think, there's been one coach for soccer. All right, so let's start filling some stuff in. Circumcenter, how's it created? So perpendicular bisectors, right? You got to associate that name with, so that symbol means perpendicular. If you can just associate those two together, it's pretty easy to remember what that means. It's like literally in the name, the two things you need to remember. It's perpendicular angles, so 90-degree angles, and it's bisecting every side. So all you really got to do is just remember circumcenter means perpendicular bisectors. Centroid, I'm sorry, centroid is also bisectors, or midpoints, I should say. So just, again, just make sure you keep that clear. Perpendicular bisectors for that. So with that in mind, what could we do in this using that, just that knowledge right now? I'm going to jump straight to the end. First part's easy. What's perpendicular mean? What can we do? I got a call on. Nayland. Perpendicular, what can we do with that? Like, that's the easy part of it. What does that mean we can write into the figure? We know it's all, we know this point is created by perpendicular bisectors. And the perpendicular part means what? So we can write it in 90-degree angles, right? We know everywhere and again, you do have to remember it comes from the sides. Like that's where the 90-degree angle is. I don't really know where else you could possibly put it, but if the figure happened to be a little trickier, just remember that's where the perpendicular part comes into play. So there, we got that. So now we know we got a bunch of right triangles. So that should again trigger. Okay, we might, if it's about if we have a bunch of information about the sides of a right triangle, that's got to trigger the a squared, b squared, c squared thing. All right. So now what else could we do? We can't, that's all we can really do with the perpendicular part. What can we do with the bisector part? Ben, you've been pretty quiet. What can we do with the bisector part? What does that mean? Like before we even worry about numbers, what's the bisector part mean? So splits, be more specific. It's not the shape, it splits what? Yeah. But the try, like you could confuse it and think this would just split. It's not just that, it splits what? The bisector part splits what? There's three of them. Anybody else who can add to it? I think you understand it, but I just want to make sure for everybody. Second. So again, this is the kind of stuff, if you can't answer this, some of you I think just don't like to answer stuff. But you cannot answer it, make sure you write it down when we say it. And then you need to study it. What gets split in half? Again, bisector means split in half, but now we gotta know what gets split in half. More than one thing. Three of them. Helen.
Want to say side. That's not.
Yeah, that's right. Yeah, we split all three sides into two equal sections, two equal segments, I should say. So that those two are congruent. These two are congruent. Again, if you couldn't answer that, you need to write that down. Again, perpendicular bisectors split each side into two congruent segments and draw in little, congruence marks kind of says it without using words. Make a note of why the congruence marks are there because of the perpendicular bisectors. So we know that's true. Let me ask you this. What is the 4.25 talking about? That's a little tricky. It is SP. So when it's written inside the figure, it's going to be about a line inside the figure. And there's no degree mark, so we know it's not about angles. I told you sometimes it gets a little tricky with the figures. And the tests are even worse because on the test, they make these teeny tiny figures and try to cram the information in there. They did tell you though also. So sometimes they'll tell you in writing because they know the figures can be confusing. So make sure you read everything they give you. So SP is the 4.25. So we can't say this is 4.25 because it's not about that segment. So how can we use the fact that we just split everything into two equal segments? Where can we do something with that? Yeah, if we know this whole line, that whole side is 7.79, what can we say then? Chloe, what can we say? We know this whole side is 7.79. What else can we say knowing now that we just bisected that side? Yes.
What's bicheck mean? So what do we do? 7.79. We split it in half. So we divide this by 2, and that'll give us each of those. So somebody do that for me. What is it? 3.895. So we'd have 3.895 and 3.895. So again, that's piece by piece. You haven't done any math to actually solve anything. What you've shown me, I understand the concept that it's a perpendicular bisector because it has right angles and it's splitting it in half. You did show me you understood to do the math and split the side in half. So I guess you did do a little math, but again, nothing super complex. You certainly haven't started to actually figure out SV yet. So what's another we want? So SV is right here. We want to try to figure out this piece, that line segment right there. So what do we, and we have one of the sides. Again, when you're dealing with these sides of a right triangle, you gotta think a squared, b squared, c squared, but you have to have 2 sides to solve. Can't have 2 missing sides unless it's like an isosceles right triangle and 2 of the sides are the same, then you could potentially solve. But this one's not. This is not isosceles. So we could say, yeah, red works. So we could say, well, I need to know one of the other sides. I'm solving for this one. So that's probably not the one they're going to give me if they want me to solve for it. So I need to probably figure out, and again, I could use either right triangle, really. So there's got to be some number I can figure out. There's only one other number in the problem, right? Now you just kind of want to try to. So now you just kind of want to back up your guess, like that's an educated guess, but you're really still guessing. You want to say, okay, well, is there something that would tell me that this length is the same as that length? Well, again, that's what the circumcenter says. The point is the same distance from every vertex. So if it's 4.25 units from that vertex, it's 4.25 units from every vertex. Okay, PU.
That.
Well, we don't know. Well, I'm sorry, we do know that they're congruent, but we don't know any numbers there though. Because this goes with that.
Oh.
Remember? It tells us that up here. So that's why I say be careful about the figures. If it's inside, it's probably going to refer to the line inside.
But could.
Yes, yeah. That's what we were just going to write in. So if we know the distance from this to P, so a vertex is 4.25, well, because of that, the distance to every vertex is the same. Again, that's the definition of a circumcenter. The distance from this point to every vertex is the same. So yeah, and again, we can use the 4.25 with this triangle or with this triangle. Because again, we know the 3.85. So yeah, we could use, that's actually the triangle I was looking at. But then Brianne said, we could use QS. It's the same calculation. They're congruent. And that would mean they are congruent triangles. Those 2 triangles are congruent. Because again, if 2 of the 3 sides are congruent, they share that side. So that side's got to be the same. Then they're congruent triangles. But to do the math, again, which side do you have to identify? When you do a squared, b squared, c squared, there's only one side that's important. Because the a and the b are being added together, right? So what do we need to make sure we identify correctly and put in the correct place? Yeah, you gotta know where C is. That's the key. Write that down. And a squared, b squared, c squared. C is the important side. It is always across from the right angle. It's called the hypotenuse, if you remember. So if this is the right angle, it's across. That's C. If this is the right angle also, then that side is C. That's how you find it. There are other ways, like it's the longest side, so you can visually tell it's longest. That works too. But this will always, I mean, that's the definition. Because remember, the biggest angle is across from the longest side. Well, 90 will always be the biggest angle in the right triangle because it's half of 180. The other two can't be bigger than 90 because they have to add up to 90, so they can't be bigger. So in a right triangle, 90-degree angle is always the biggest angle, which means the side across from it is always the longest side. So if we plugged it in, I'll just really quickly show you that I'm not going to do the math. You can solve it out yourself. A and B do not matter. I could make 3.85A. I could make it B. It wouldn't matter because ultimately they just get added together anyway. And then 4.25 squared. I'll give you a minute to solve that out. And then you guys can give me the answer so everybody can check their work. Did I steal somebody's pencil? Oh, well done. But we should get through the other one that has a lot of math today. Is which one do I may skip? We may just do both of the next two really fast, and then we'll have more practice times. Thursday for you guys. Anybody done yet? What do you get? Let's see if that makes sense. Again, if that's 3 and that's 4, that should be shorter. So 2.93 makes sense. So we'll just confirm, make sure other people get it. I got the same thing. 2.93. All right. So if you don't get 2.93, we can talk about that. Just like make a note or something. Phone should be up. Shouldn't have phones out. There's some of us just joined us, but phones should not be out. So again, put it up. Just you don't need that when it comes out. When I say that, you're busted. Any questions? Again, that's about as tough it'll now. When I say that's as tough, remember there's 3 different types of triangles where you're going to have that level of difficulty. You keeping everything straight is going to be the tough part. Understanding when do I do this kind of math? When do I do the next kind of math? All right, let's go to the next one. So now go to the next. Should let you practice, but I want to get through everything so we can just practice right before the quiz. That way you can do a lot of repetition right before you do the quiz, and then you'll just be repeating the same thing as opposed to like finishing this today and then forgetting about it. So go ahead and go to the angle bisectors chapter, specifically page 355. Actually, I guess I need to do that too. And some of this, I mean, the math is still similar. You're going to be using some of the similar stuff, but that actually kind of makes it a little more confusing. One more. All right. So we did angle bisectors. We drew them in. We said they needed a point. That point of concurrency is called the incenter. I don't know why I circled it in. I'm going to zoom in and then so let's zoom in first. So here's the math on this one. So again, we create it with, so this is your memorization part. We create the incenter with angle bisectors. So angle bisectors. Now here's the weird part, or the tough one. you'll notice I also have 3 right angles in this triangle as well, after it's created. So you can easily get this confused with the circumcenter because we created that with perpendicular bisectors. So we had 3 90-degree angles on the sides for that one too. What's the big difference? Like, how are you gonna know? I mean, first of all, you can memorize it and just know if I tell you it's the incener, that it's not perpendicular bisectors. But how are you gonna know? Like, so what would you, so if you see that the angles are bisected, which again, this is, they're not doing a great job, but this is 2 sets of 3. It's not just like 3 all the way across. So that's telling you that those 2 little angles are equal. All these are equal. So these 2 here are, this little angle equals that little angle. This little angle equals that little angle. So if they give you the congruence marks, you'll know, well, this is created though by bisecting angles, not by bisecting the sides, which is kind of the other thing I was going for. We're clearly not, this is not a perpendicular bisector. It's perpendicular, but I'm not bisecting it. Again, you can't always go by scale, but sometimes if it's that far off, you can say, well, there's no way that it can be bisecting all of the sides if it's that far to the left or right or something. So if it's not in the middle, that can't be a perpendicular bisector. So here's what this is telling you. So again, this is the incenter. It's up right above this figure, but it's called the incenter. The incenter is created again by angle bisectors. So it's created with angle bisectors. So all the angles are congruent. I'm sorry, each angle has a pair of congruent angles. The next piece, which we learned already, the next piece, today's piece, this point of concurrency, the incenter, is the same distance from every side. So the circumcenter was the same distance from every vertex. The incenter is the same distance from every side. That's why we have right angles. Remember, we measure distance to a side or the distance to another line at a right angle. So it is the same distance to every side. Now you might get the same kind of problem on this because we have 3 right angles, right? So we're going to have right triangles again. So all of these are right triangles. It's very possible I could give you enough information to do the exact same thing. I'm not going to spend tons of time on this one. Let's maybe do one. So look at example 3. And then you'll notice they are using the right triangle a squared, b squared, c squared thing. So they ask us, or they tell us first, P is the incenter of XYZ. And it says find each measure. So they want PK. Here, I'm going to zoom way in a second, but you have it in your books. So they want PK. So I'll write it here. And what else do they want? Angle LZP. So now I can, what else? All right, so again, do what you know. Part of this is dependent on you memorizing things. If you don't memorize things, you won't even know where to start. I mean, you probably still make a guess, but if I know it is the incenter, how is it created? You just say, you just written down. The incenter, how is it created? Anthony, you know? Just written down. Israel, how's it created? Just wrote it right next to incenter. Angle bisectors, right? Perfect. So if I tell you incenter, you need to make the connection to angle bisectors. Now you can start filling information in. One hit might be sometimes that they give you information about angles. I'll tell you right now, though, on the quiz, I'm probably going to give you information about sides and angles in every problem. You're going to have to really know your stuff. So if it's an angle bisector, now I'll let you answer, Adam. What else do I know? What else can I fill in? I'm gonna maybe get to that, but like, let's do the easy stuff. If I know they're angle bisectors, I know some stuff about angles, right? They've given me some stuff, so what can I do? I'll give you a hint. I know this, 25.1. I know this, 24.6. And I know that I have angle bisectors. Yeah, so that means all of these are congruent. Well, I should do this. 2 of those there. These are congruent. So if that's 25.1, that's 25.1. So again, this is all dependent on you memorizing stuff. Like, I know you guys don't always put a lot of time in before quizzes. This is one where you're going to have to. Otherwise, you're going to owe me tutoring if you plan on precepts. It could be a lot of tutoring. So I can fill both of those in. Now I could go ahead and write it in, even though I don't have angle measures down here. I could say, well, I also know those are congruent. So let me ask you this. What else can I fill in? There's one really tricky piece. You got this idea. And it's about angles. I'll even give you that. I can fill more stuff in about angles. So we know there's 90. So we know there are some 90-degree angles, right? So we're getting closer to what else the big leap we can make. So what's the leap that I'm talking about? One more leap that we can make about angles. Again, something that we've drilled home that you should know automatically about triangles. Yeah, all triangles. Everyone, doesn't matter if it's right or not. So if I know 2 of the 3 angles of a triangle, which I do, I know that's 90, I know that's 25. I actually know all of these are right angles, right? If that's 90, I can't do it. I'll do it and then erase it. Remember that? 180. So if I know that's 180 and I know that's 90, then I know all of these are 90. That's 90, that's 90. So I know 2 angles in every triangle except for these down here, which I kind of know those down there. Anybody tell me how I know these down here, even though I don't know either one of them? Really? I used to give snacks. I'll give snack out for that. Anybody can tell what in the world? Yeah.
Yep.
Yep. You just don't want to get turkey out, do you?
Yep.
Yep. You got it. But you can't stay in here.
I'm not. I'm just writing my name on the board.
I mean, you've got it blank. Oh, you're already up there.
Oh, already up there.
All right. We'll get in trouble. So how can I figure out these when I don't know either of them? Back on the line. There's a stack on the line. Doritos, Takis. Oh, Cheetos. Yeah. Oh my goodness gracious. He's checking out a blanket too. Oh, I thought your hands like you were a TA or somebody. I didn't see it. All right, write your name up. Hello, Kiki.
Where?
What's it? It says Kiki.
It's home. Oh,
You'll find it.
where's the?
Okay, so here's the question. First person gets it. How can I don't know, like we knew these angles, right? We knew the 90, those were pretty easy. I don't know another angle in here to solve, like, right? Any of those in the corner or check out. So I know these two, that's how I could solve. But how, I don't know like this angle in order to have two angles. So how can I solve for that third angle? Hey, you're back.
Yeah, so. I know it.
Right now, come back forth so I can have it ready. Which one are you doing?
I'm gonna do two, because I was gonna study this.
Doing two today?
But you want me to do it that much or something?
I want you to study is what I want.
I studied for one already, I just came, actually, it was the graphic piece wise. What else?
All right, so let's just come in and now that I know that one, I'll let you do that one and then we'll talk about the other. And I can have that one. So how can you solve for those two angles? Let's say it again. Tell me what, so use letters. How would we solve for LZJ though? I don't have anything now. And then what's the last step then if I wanted to know just that top one? All right, so if you didn't hear what Frian was saying, I may not know any of the little stuff, but don't forget, I know all of this. There's always a big, well, not always, yeah, always. There's always a big triangle you can use as well. Don't get caught up on just all the little triangles. I have a big triangle. All of the angles in a big triangle add up to 180 also, like every triangle. So what Priyan said is if I add up these, that tells me what this angle is. So that's 50.2 there. If I add up those, that is what, 49.2 up there. Again, I'm just adding the two angles together and that makes the big angle. So now if I add those together, what do I get? 99.4. So I could say 180. Subtract 99.4. What would that be? 80.6, I believe. So this big angle right there, somebody can check my math. So everybody has the correct answer. So I believe that big angle should be 80.6, but I know it was bisected, right? Which means I just divide that in half. So again, this will be as complex as it gets. If you're at least following this enough to fill in pieces, and you practice a little because you're definitely gonna have to memorize and practice, then you'll be okay. So now I would know each individual angle there, and now I can solve for anything I want. I don't really have any, well, actually I do have some information about sides, so I could even use some information about sides. I don't think, oh yeah, we do need that. I'm sorry, we do need that. Because we need to solve for side PK. So what is it that I know? So now let's talk about the side. So that's how you would solve for angle LZP. We'll do it in a minute. How do I solve for, like, what do I know about sides in this? There's only one real thing that you need to know, and then you can solve. What's true about the incenter when it comes to sides or line segments? This is the main thing you need to know about the incenter. And well, in addition to the fact that it's created by angle bisectors, the incenter itself is what? But what's the is in the center, but center means a lot of different things. What is the main concept? What's that ever called? What do I know about the incenter? In your book, read the definition of incenter. It's in that little box where it's like a theorem or something. Somebody just said it. Didn't sound like. What's the
The incenter, so this point right here. Oh, I know what I'm gonna do. Change colors. Just do something super bright. That point right there, oh, it's kind of still green. But it is the same distance to every side. That's why we have the right angle symbols, because that's not drawing in a perpendicular bisector. It's representing the distance to each side is the same. So every one of those lines is the same. Well, if only we knew one of those lines, we could figure out what PK is, right? Because it's the same as all of those. But they didn't give us one, so what can we do? I say right angles and we talk about sides. What did I say needs to pop in your head? A squared, B squared, C squared. Sides of a right triangle, A squared, B squared, C squared. And I know two of the sides. Right, 7.3 is this side. 5.6 is this side. Now be careful. What side do we have to identify? What's the important side? I said the hypotenuse, or C. In this case, we know C. I guess in the last one we also knew it. So I'm solving for one of the short sides. So again, doesn't really matter which one I make it. So that's a short side. 5.6 is a short side. And then the hypotenuse C is 7.3. So that would be your answer. So I'll let you try to solve that. A squared plus 5.6 squared equals 7.3 squared. My guess is it would have to be lower than the 5.6 for sure. Maybe in the high 3, low 4 range. Something that hopefully comes out around there. Good answer. Something in that range. Something in the 4-ish range. No? I'm just guessing. Knowing other right triangle numbers, I'm just kind of guessing because there's definitely no way to do that. You hit the second. If you don't remember how to do square root on those calculators, you'll definitely need on this next quiz. You hit that second function button. Then you actually hit the button that says x squared, because the square root function is right above that. That's why you're hitting the second function first. And then you put the number in after that. And then you hit equal. And like I said, it's got to be, I would think, somewhere around 4.68. Is that what other people got? Fine. So 4.68 then would be this one. So 4.68. And then what about angle LZP? We have all the information we need for that. So where is L? So LZP is this angle. Oh, we actually already solved for it. So in just kind of figuring stuff out, we already solved for it. LZP. Hopefully, well, I mean, you can look in your pages, which aren't as cluttered. LZP is this angle right here. This one right here. So again, you follow the letters, the vertex is in the middle. LZP, well, we already saw for that when we said this whole angle is 80.6. If we split it in half, we get 40.3. So LZP is 40.3. Any quick questions on that? Let's go ahead and do, even though I know this is a lot, so hang in there. Let's go ahead and just get the lesson out of the way, and then we can just practice problems all day right before the quiz. And I think that's better than trying to learn something new and then forgetting this stuff and not practicing it on Friday and practicing it today instead. So go ahead. The last one we're gonna do today for sure is yeah, I mean, we've already done it, but we have to learn one more thing. Yeah, so go to 361. So we're back to the centroid. That was a lot going on in that feature. That's not closing. Close. Is that not closing? Oh, it's pinned. I'm sorry. Right, unpin it. Ah. There we go. All right, so what I say, 361? I do want to assign problems. All right, so here's the last piece. I probably won't make the math too complex, that you can see it more complex. So first of all, how is the centroid created? Here's what you got to associate first. I tell you, you have the centroid in the problem. 361. 361. How is it created? That's the first thing. No, that was the one that we did already. So one was created by perpendicular bisectors, which we did. One was created by angle bisectors, which we did. So this has to be created with a different method. What is it? This is the medians thing, where we're going from a vertex to a midpoint. So also that's the first thing. When I say centroid, you need to understand all of the sides are split in half. We have midpoints. So again, you got to keep that straight with the perpendicular bisectors one, circumcenter, because that was midpoints also. So centroid and circumcenter are midpoints. Actually, again, there's still going to be a lot of memorization. Centroid and circumcenter both start with C, right? Well, they also are the two that involve midpoints. So if you can remember one of them is associated with midpoints, then the other one that starts with a C is associated with midpoints. Because incener doesn't start with a C, orthocenter doesn't start with a C. So if it starts with a C, again, centroid and circumcenter both start with a C, they also both involve midpoints. It's just that one uses perpendicular bisectors, that's the circumcenter, one uses medians. Which again, the definition of a median is it's drawn from a vertex to. So here's the math behind this, and it gets more complex. So we already know we have midpoints. So immediately we can do this. We know that's true. They are not angle bisectors. Don't get confused and think we have angle bisectors. It kind of looks like it here. That looks pretty close to angle bisectors. These don't look as much like angle bisectors, but depending on the figure, it can look like that. That's why you got to memorize. The math is the centroid splits every median into a ratio of 2 to 1. So I'm just going to put numbers in there to show you what that means. It's the best number to use. If this is 1, that line is 2. So the longer part of the median is twice as long as the other part of the median. So if this is 1.1, kind of close to the same length as that other one, well then this is 2.2. And then again, down here, this one's significantly longer. So if this was 2, then that is 4. So again, the point splits every median into 2 segments, and they're not equal segments. One segment is twice as long as the other segment. So I'll color code it. That red line is 4. That blue line is the 2, and then that would be the way it would be for all the other points. The longest section, the red section for that line, is twice as long as the blue segment. I'm going to give you a formula, but that's the concept with numbers. So if you were missing numbers, still writing. All right, so I'm going to kind of get rid of some of that. Again, it's recorded if you really need it. So if we know that is, or if we don't know what that is, this is where the math comes in. If you don't know what that is, you can't solve for this, but you could potentially still create an equation because this is not a completely unknown variable. It's not like that's y. We don't have to use a separate variable if we don't know both of those sections, because we know there's a relationship between those 2 sections. What's true of this section here, PA? What do we say? It's 2 times the short section, right? So this is 2 times that variable x. So that allows us to keep it to just one variable, even though there's actually 2 pieces we don't know. And in addition to that, AM, the entire median, is equal to 2x plus x, right? That would be the whole length. If we added both of those lengths together, we could get that. So let's actually do this because it's the same for every median. So the median, the entire median. Here, you write whatever you need to. The total length of the median. I guess I could write that. So the total length of the median then is x plus 2x. So again, it's not really a variable either. What is it? What's x plus 2x? Oh, come on, how do you x plus 2x? If you were solving, 3x, right? So the total median, if we set it up like that, would be 3x. So there's still only one variable, which means you can, even though you might think you're missing a lot of information, you're not, because they're all related to this one smallest segment, basically. That's really the only unknown. If you know that, then you can figure that out, which means you can figure the whole thing out. Or vice versa. If I tell you the whole thing, then you can figure out the shortest side or the shortest segment, because it's really just going to be divided by 3. Because I would say, well, the total median is that. Well, if the total median, here, I'll just do one. I want to know what is PM. That's what I want to know. And I'm telling you AM, oh, that should be capital. AM equals 9. I want to know what PM is. You solved it. Again, didn't give you a lot of information, because you don't need a lot in this kind of problem. So what is the length PM? And I told you the length of A. And with these kind of numbers, you can probably just kind of figure it out. But it'll definitely be a little trickier on the quiz, but for now, the concept will work. We'll do a practice with it. Yes, probably a little trickier. Yeah, not really. They're pretty much the same kind of problem. That's funny. I would make sure I wrote that Actually, I'm gonna write a different formula. Write it all in words. Those of you that struggle with variables. Raise your hand if you think you got it. Okay, take that. So again, if you just kind of think about it, you might just be able to figure it out without using any equation when it's just a simple number. I know this has to be twice as big as that, right? That's the main thing you have to remember. From there, if you can set an equation up, great, but let's just, I know AM, I know this whole thing. That whole thing has to be 9, right? So that's got to be 9. That's, this has to be 9. Plug in numbers. You got a calculator, plug and play for a little while if you have to. Pick one. Well, this has to be 2 times the 1. Did I get to 9 total? 1 plus 2 is 9. No, that's not 9. All right, try another number. 2. So what's that one got to be? Yeah, I mean, as long as you remember the relationship, I get to 9. Oh, I'm at 6, right? Getting closer. I haven't gone over it yet. So let's say I jump and I say, well, I'm way too low. Let me go with 4. So what's the other longer one have to be? Is that 9? Now I'm too high, right? So I got to go backwards. And you could even do this even if it was decimals, it would still work, especially since you got a calculator. This one won't be a decimal. So what's the longer one? Is that 9?
Yep.
Bam. So again, there's an equation you should set up, which I'm going to give you in words right now, and then you can do the check problem on your own. So instead of this total length of median equals 2x plus x, I'm going to write it in words for you. I think for some of you that will be helpful. Let me make some room first. So here's your relationship when it comes to the central. Red probably can stand it. So the total length of the median going to equal, again, median is from a vertex all the way across to a midpoint. Again, we know we have midpoints of every side. We want to solve for that total length. It is the shortest segment. So if you want to write this near the picture, the shortest segment would be PM. The total length of the median would be AM. So PM is the shortest segment of the median. And I'll go ahead and write in of median. So shortest segment of the median plus, and I'm just going to write it completely in words, 2, the number 2, times the shortest length. And that would represent the PA part. Because PA is 2 times PM. So that's your formula in words. If you're better at memorizing something in words, and then just depending on what I give you, you'd plug it in. Like maybe I give you the total length, but not this. Well, then you'd plug this in here, and you'd have to know that, now you would have to know that you can combine these two things. So again, the formula would be x plus 2x. If you needed to solve out, and that's median. And then depending on what information I give you, you just plug it into the right spot, you solve out. Any questions? Go ahead and try to do the example real quick. Shouldn't take long, the same thing I just did, and the check problem. I actually scratched the check problem because I used the same number they used. So we just did the check problem. So go ahead and just do the example then. I did not look forward. What are the odds that I guessed the same number? Actually, they're pretty good. So just do the one where it's the example. I think the median is 6. I'd try to set the equation up if I were you. Don't just plug in numbers and practice that, because when the numbers get harder, it's going to be more difficult to just plug in numbers and guess. Oh, question. Emergency, you can run out. You got 3. Well, you can't write a passport, but I mean, if it's an emergency, go. Don't sit in here if you have an emergency. I'm not allowed to run traffic for class. If you guys ever feel sick or any of that stuff, like it's truly an emergency, you don't have to ask anyone. Question. So example, no, the check we just did on the next page, I don't happen to guess the number they used. So yeah, you're doing the example 1 on the bottom of 361. Where I think the only difference is they use the number of 6 for the median instead of 9. Now they give you that formula. If you want to use their formula, that's fine. They say BP, they're solving for the smaller segments. I'm giving you a formula related to the median itself. So again, you can solve it using any of them. You'll see when we do problems, they're going to give you different information. So there's no one for you're always going to have to like figure it out depending on the information they give you. If you understand their formula, if you want to use that one, then you do the quiz, that's fine. Oh, I'm sorry, BL is the lock-in. Oh, let's stop there. Oh, crap. I forgot to give you some problems. I don't know if any of you, I will put some IXLs in also. I'm going to really try to do a better job of giving you IXL, although I don't remember IXLs are never going to be as difficult as what you're going to see on a quiz. So don't rely on just IXL, but if you're struggling or if you just need more practice on the like concepts, IXL is good for that. If the math is not very difficult on really IXL. The book is much better for that. All right, see you in 2 days. Yes, ma'am. Yeah. Let's stop recording real quick.
I was wondering if I could just redo the questions I know.
No, you can't do that. No, we don't do test corrections. We do retakes, which means you got to do the entire test. I can still show it now.